All right. This is attempt 5 at this video. I am sorry. I'm not in class today. I am not feeling terribly well. And yeah. So we were going to do this with me in class today, but I cannot come in. Yesterday I was at a math training. Today I am not okay. Not because of the math training. There's something going on. Anyways, trig derivatives. I have your tests graded. I'll get them to you on next time I see you. I'm really sorry it took me so long to get those to you. They're done. They're graded. They're ready for you. Yeah. We did these two. With magic. We found that this derivative of sine was cosine. And derivative of cosine was negative sine. We will look at them again. When we get to L'Hopital's rule, I think third quarter, we will look at these again. And we will actually prove that the derivative of sine is cosine. It uses squeeze theorem as of right now. But squeeze theorem's not on the AP test, so I didn't chew up class time with it. And we use tables and graphs to figure that out. And it's real hand wavy. And I'm sorry, because it is funny. Now, we're going to do these 4 today. Tangent, surprisingly, we've already done. We did it on the quotient rule homework. I think it was probably, I don't remember where exactly, but I know it was there. And we're going to do it again anyways, though. We're going to do it again today. And we're going to use chain rule and product rule exclusively today. No quotient rule today. Julio, no quotient rule. I want you guys to practice chain rule and product rule is the reason. Quotient rule is a nice shortcut, but we are not at the time of the year where shortcuts are good for us. Chain rule, product rule, practice, fantastic. Let's write these down though. C prime, derivative of the outside function times the inside derivative of the inside. But inside function, that's g of x. Leave it alone inside there. It's inside. It's sheltered. And then on the outside, we're going to multiply by its derivative. I love product rule. It's so pleasing. Derivative. Normal. Big old plus sign. Normal. Derivative. If you don't want to write it this way, don't worry about it. You can write it however you want. Kind of, right? You could flip these around. Multiplication's commutative. Flip those around. Multiplication's commutative. You could flip all of them around. Addition's commutative. The only thing that you have to make sure is that f prime goes with g and f goes with g prime. However you want to write it is up to you. I like it this way. I write it the same way every time. That way I don't miss anything. Quotient rule. I am done ragging on quotient rule. I love it. But what I don't love is when students make mistakes with it. So let's not make any mistakes with it. F prime of x times g of x. That looks a lot like this, which is where the biggest mistake comes in, because it's no longer a plus, it's a minus. And if you don't remember where the minus is from, or came from, do it again. Practice with chain rule and product rule. Do this and find the quotient rule. Big hint though, this is going to have a negative exponent when we move it upstairs. And when we take its derivative, that's where the negative comes from. comes from the negative exponent. All right. F of x, g prime. Notice these are very similar. Very, very similar. That's why I write this one the same every time. That I grew up making mistakes with this. And I don't want you to. Now, we're not done with the quotient rule. Because all of that is being divided by g squared. The denominator squared. Okay. If you haven't written this down, take a couple seconds, pause the video, write this down. You need these. You need these two. That one's a shortcut. It's beautiful, but we're not using it today. Julio? Nope. Okay. If you needed more time, you could just go back and pause the video for that last one. We're going to work on this side now. And I can't stand that video angle. We're going to be right here. Okay, stop moving, camera. Okay. We know the derivatives of these two. You probably know these. We're going to use some trig identities that are not written here, just one or two. I know that we've done this already, but we're going to do it again, just so it's in the same place as these three. All right, here we go. We're going to go f of x, and we're going to change it. We're going to change the way that that this function looks, because this is not helpful. Break it apart. Sine of x over cosine of x. That was one of those trig derivatives I mentioned that's not written on this paper. That is very nice. All right, a Borat is going off in my head right now. Next, I don't like this because we're not using quotient rule. We are practicing product rule and chain rule. So sine of x, oh dang it, I'm running out of space, times cosine -1 of x. All right, I need to give myself more space next time. We can take our derivative now. We can take the derivative of f of x. We have a product. All right, that's going to be derivative of this, which is cosine, times cosine inverse. Oh, I'm running out of space. No, oh, dang it, why did I say inverse? It's not the cosine inverse. It's cosine to the -1. Don't call that cosine inverse. It's cosine to the -1. Dang it, and I'm really running out of space. Minus, oh sorry, plus sine of x. You'd think by attempt 5 I would give myself more space and stop saying silly things. Dang it, I'm over here already. Cosine to the -1. That's what we have to take a derivative of for this part. All right, and I'm already over here. Okay, so this is a composition of functions, right? Cosine -1 of x is the same as cosine of x raised to the -1 power. This is a chain rule problem. All right, so I'm going to multiply by the derivative of this. Derivative of the outside, that's going to be -1 times, and I know that it's going to be raised to the -2nd now, and that's going to be cosine raised to the -2nd times the derivative of cosine, which is negative sine. Okay. I knew I should have made this paper bigger. It looked bigger on my computer screen when I made it. Okay. I'm going to rewrite this. I need more space. Cosine of x over cosine of x plus sine of x. Dang it, I ran out of space again. Let's rewrite this so that it's a little bit nicer. The negative ones, there's one here and there's one right there, are going to cancel. Sine of x is going to stay in the numerator. Cosine squared is going to go down and be a denominator for us. Okay. Okay. Oh, I can simplify even more. I can combine these two. Okay, I'll do that. Sweet. All right. Now I'm no longer over here. I'm only working on tangent now. So, sweet. I can see that this would simplify to f prime of x equals 1 plus tangent squared x. Oh, that's cool. 1 plus tangent squared is the derivative of tangent. Turn your head. Look at that back wall. That's not written back there. What the heck? This is the derivative. But you might be noticing something else. This has a Pythagorean identity that turns it into secant squared, which is written back there on the wall. Well, I guess when this gets projected. That way? Okay. Now, let's not use that trig derivative, though, or trig identity. Let's multiply these by cosine over cosine. Fancy one. That way we get cosine squared as a denominator. And we can combine like terms. Or look at that. We have common denominators. We can add the numerators. Cosine squared plus sine squared. That's 1. So f prime of x equals 1 over cosine squared of x. That is secant squared. Right? Yeah, it sure is. Look at that. 1 over cosine. 1 over cosine squared. That's secant squared. And that is what's written over there. Let's go ahead and put that over here. Tangent. Secant squared x. Beautiful. So nice. But you might notice that we found some other flavors of this derivative. Here's one. Here's another one. super helpful, not necessary, but you could totally use these down the road if they're more advantageous than this. All right? All right, let's move on to this atrocity over here. G of x equals secant of x. Dang, I cluttered all of this in here. Oh wait, that's not bad. Isn't secant equal to cosine raised to negative 1? Huh. All right, so that's nice. We can, right, because that's secant is 1 over cosine, and that's this. So we need to take the derivative of that. Wait, didn't we do that already? Oh yeah, it's right here. Wait a minute. Is that right? Did you guys catch that already? I bet you thought I was writing over here because I didn't have a space. I planned this. Cosine raised to negative 1. Here's our derivative of that. Thank you, product. No, chain rule. Thank you, chain rule. And then we get down here. Look at that. Sine over cosine squared. Wait, that's not on the back wall. That's not over there. All right, I'm going to actually pick up the pen and start writing now. That means that g prime of x is equal to sine of x over cosine squared x. If I went too fast there, just pause the video. You can pause me now, and you can talk with each other and ask, what the heck is Mr. Evans talking about? Hopefully, somebody tells you cosine to the negative 1 gets you this derivative with chain rule. This we simplified to that. That means that our derivative of g prime would be sine of over cosine squared. And this can be broken apart into 1 over cosine times sine over cosine, which also is not written on that back wall. But it's getting closer because this is secant. And this is tangent. And that is written on the back wall. Okay. All right. Sneaky, sneaky, Mr. Emmons. Secant. Derivative is secant times tangent. That's goofballs. Did I do that right? Yep, secant times tangent. Very goofy. Look at that. Derivative of this is itself times tangent. You know what would be fun? Is finding the second derivative of secant. Find the second derivative by taking derivative of this. That would be fun. All right. Okay. Let's not get sidetracked. Let's get cosecant going. Cosecant. It's probably going to look a lot like this, right? Because cosecant is a lot like secant. All right. I'm going to pause the video. I'm going to do it, and then I'll talk about it after. Alrighty, folks. So h of x, 1 over sine to the negative 1. just like cosine -1, we have a composition of functions. Chain rule applies now. All right, power rule. Drop that -1 out front when we take the derivative. Raise the exponent to -2. I know that we're minusing 1 from -1, it gets -2. Leave the inside function alone. So inside function was sine of x times the derivative of sine, which is cosine. Almost exactly the same as this. Then we have an extra, oh yeah, we had an extra negative here. All right, rewrite all this gobbledygook. We've got sine raised to the -2nd power times negative cosine. All right, I want to rewrite it like this. That's so much better. We could be done here, right? But no, simplify. This is not written on the back wall. Spread those things apart. We got sine squared on the denominator. Split them apart by multiplying. And I'm going to leave that negative out front. So negative 1 over sine, that gets us negative cosecant. Here it is. It's cosine over sine. Shoot, that's cotangent. Here is our derivative of cosecant. And that's beautiful. Alrighty. Cosecant. Negative cosecant times cotangent. That is a beautiful pattern. Look at that. Secant, cosecant, tangent, cotangent. There's a negative sign. Okay. Next up, cotangent. All right. I'm tired. I am tired. It's 3 in the morning. I've been at this for about an hour and a half. 5th time making this video. I didn't like the other ones. And I'm making it the way I like it. So, we know that j of x is equal to cosine over sine. And we could totally rewrite this as cosine times sine raised to the -1 power. I don't want to. I want to write it as cosine times cosecant. I want to change things up. All right, this is just a different path than we've taken so far. I mean, we took identical paths here. We did this one while we did that one. So let's just do something different. Okay. We're going to take the derivative right now of this j. Derivative of this, we've got to take the derivative of that first thing. So that'd be negative sine times cosecant. Big old plus sign. Not big. I don't have enough space. Cosine, leave it alone. Leave it alone. And now we have to multiply by the derivative of cosecant. Funny thing, we know what the derivative of cosecant is. We just found it. There it is. It's negative cosecant times cotangent. I don't have enough space here to write that, so I'm going to write it right here. Negative cosecant cotangent. And that's the derivative of cotangent. But we could make it prettier. Negative sine times cosecant. Cosecant, why, that's 1 over sine. We've got a negative symbol here. I'm going to put that out front. Big old minus sign. And cosecant again. Cool. I'm going to write cosine over sine. That's these two. I still haven't written cotangent. Okay, I'll put cotangent here. Wait a second. Wait a second. This is looking weird. That's a -1. That's a cotangent. Does that mean this is true? It sure does. This is one flavor of a derivative for cotangent. Just like this is a derivative of tangent. And just like this one, we could have taken a different path. We totally could have gotten common denominators and turned this into a cosine over sine. And if we did, I'm not going to do it because you guys are smart. This, and if you don't see it, you should do it, would be -1 over sine squared, which, oddly enough, is a negative cosecant squared x. And that's the nice derivative of cotangent. Negative cosecant squared x. All right, I am so tired. I am really sorry that I'm not going to be here today. I'm sorry I wasn't here yesterday. Yesterday, I had no choice. They told me I needed to go to a math training, and yeah. Now, you guys get something beautiful to work on. Next week, we are going to do a quiz. And this quiz has the same concept as Gelsinger's unit circle quiz. You have to, as a class, get 100%. Of this. So if you want all the answers to next week's quiz, they're right here. I would use the remainder of today to commit all of these to memory. Or get really good with chain and product rule and quotient rule. So you could just make these on the quiz. On the AP test, you have to have these memorized. There's no formula sheet. These need to be memorized as soon as possible. Next week, unit circle style mastery quiz for trig derivatives and derivative rules. All right, you all have a wonderful day, and I am so sorry I'm not here. I really want to be. I'd way rather be with you guys than what I'm doing right now. I don't feel good. All right, have a good weekend. I'll see you guys on Tuesday.